All right, boys and girls, we are starting section 4.4, which is trig functions of any angle. And I'm going to start off with example 1, which is evaluating the trig functions. And you can find that on page 284. Just a little heads up. I did this index card, and this is coming from the chart right above example 1. And you're going to use it often, so I would do an index card for that one as well, okay? And I will be referring to it often, so make one, keep it handy, use it, okay? It helps from flipping pages constantly. All right, boys and girls, let's start with example 1. Okay, so for the first example, we're going to be doing the checkpoint. And basically what that says is let -2, 3 be a point on the terminal side of the theta. Find the sine, cosine, and tangent of theta. Okay, so this is what's given, and this is what we have to find. Okay, so I just kind of set it up for you. If they give you a point on the terminal side of the angle, then this is your x value, and this is your y value. Okay, and so now you're going to refer to the index card. If you notice, sine is y over r, cosine is x over r, and tangent is y over x. So we can kind of start setting up some stuff. Okay, so based on this, I know that my y value is 3. I know that my x value is -2. Okay. And based on that, I managed to set up tangent of theta, and I've only put the numerators for sine and cosine. Notice we need to solve for r. We don't know what r is. So this is when you use the unit circle formula. And this is just the unit circle formula. So r is radius, and the radius is going to be equal to the square root of x squared plus y squared. So we're going to be using this formula to help us solve for r. So that'll be side work, okay? So r equals square root of x squared plus y squared. So let me bring that down. So this is what it looks like so far. So again, we know that x is -2, so -2 squared plus y. Y is 3 squared. -2 squared is 4, and 3 squared is 9. So this is 4 plus 9, which is 13. And of course, we want the square root. So this is our r value, okay? R is square root of 13. So now, once you solve for the radius, you can just come and insert it. So this is square root of 13 and square root of 13, okay? Obviously, we can kind of clean this up a bit because you know that we're not allowed to have radicals as denominators. And I've already showed you in the previous videos how to get rid of that. So by now, you should at least know some shortcuts. So what you should get is square root of 13 over 13. This one should be 2 radical 13 over 13. And of course, the fraction is negative, so -2. And then this one is just, it'll stay the same, but let me just clean it up. It'll be 3 over 2, and of course, it's negative. Okay? So your sine of theta should be 3 radical 13 over 13. Cosine of theta should be 2 radical 13 over 13, negative. Tangent of theta should be -3 over 2. And that's it. We just evaluated our trig functions. Okay? Awesome. And then this was the checkpoint. But I'm going to give you guys one more before we move on. Okay? All right, let's try another one. Okay, so I'm going to call this my extra example for number 1. And basically, the instructions are the same. Let 7, -4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. All right, here we go. So remember, this is where you're going to start to use your index card, okay? Sine of theta is y over r. This is our y, so we're going to write -4, and we're going to figure out our r. Cosine of theta is x over r. This is our x, so we're going to write 7, and then we're going to leave that blank because we're going to figure out our radius. And then tangent of theta is y over x, so that'll be -4 over 7, okay? So your tangent's complete, but we have to find our radius. So for that one, we're going to write, again, same formula. Radius equals square root of x squared plus y squared. So r equals x squared plus y squared. Okay. Our x is 7, so 7 squared plus -4 squared. 7 squared is 49 plus 16, and that's 65. And we want to take the square root of 65. Okay. By the way, the question was asked for me before if we always have to simplify radicals. And the question is yes, you don't even have to ask. Always simplify your radicals. Do we have to simplify fractions? Yes. Again, you don't even have to ask. Just make sure you do that every single time. Okay. So now that we have our radius, we can come over here and plug it in. And this is square root of 65. Okay. Sorry, I ran out of room. Okay, but again, by now you should be able to clean these up, okay? No radicals in the denominator. So just remember, again, it's a given. Automatically have to simplify it, okay? So I'm going to erase this just because I ran out of room. Okay. So if I clean this up, we should end up with -4 radical 65 over 65, okay? And then if I clean the second one up, we get 7 radical 65 over 65. Okay. So sine of theta is -4 radical 65 over 65. Cosine of theta is 7 radical 65 over 65. And of course, tangent is just -4 over 7. All right. Awesome. Okay, so let me give you some examples. And for example 1, you should be able to do numbers 11 through 22 on your own, okay? But now I'm going to give you some to try on your own.